at rate 10 meter, what will be the velocity after end of this strike? Nothing but using the v square minus u square formula, we'll get the answer. So
Okay, sir.
200, 400, that is equals to 0 is equals to 2 into 10, 20 into 20. So answer would be 20. So this is the
Yes,
answer.
sir.
A
20.
cyclist does not come to rest immediately after stops paddling due to inertia of motion. And man
Yes, sir.
of same basically moving with a truck of mass 2000 kg from 19 to this, change in momentum would be negative. And if negative is not mentioned here, don't worry about it. The magnitude
Um,
would be same. So that would be uh, 25. 25 and this is 20. So minus 5 minus 10,000 this one. Car moves with a constant speed around a circular track. That means it is in accelerated motion because the direction of
yes.
the body is changing. If the distance of the object is double, the gravitational force will become 4 times smaller, 1 by 4. Because if you do the double, the square of the distance between them do it. Next is if the distance of the graph of a body is parallel to the time axis, that means the body is at rest. So all the, I think it's like as the MCQs, so we have done such kind of questions definitely in the class, right? Now let's come to the assertion reason part. A stone is feather and a feather is dropped in a vacuum at say fall at a same rate. In the absence of air resistance, all fall. Obviously, that is true. Assertion is true, R is true, and R is the correct explanation of A.
Correct
Wait,
explanation.
yes.
Yes, sir.
And next is basically the table, okay, mass of Earth.
This
Okay.
one I'm actually confused. I didn't.
Why is the weight of the moon less than on Earth? Because it has basically less acceleration due to gravity. Na? We have discussed that if the body is having less acceleration due to gravity, the weight would be different. On Earth, the
Okay.
acceleration due to gravity is more as compared to basically moon. That's why mass is fundamental. Mass is not going to change at all. But the value of the weight would be changing when you are basically going from one planet to another planet. Calculate the acceleration
Okay.
due to gravity in the first case using the above data. Simple. Acceleration due to gravity, nothing but
Yes,
weight upon mass, right? Weight
yes,
is
sir.
equals
I
to
did.
mg, na? So it would be 49 divided by 5. That is equals to 9.8 meter per second square. Isn't it, Harshita?
Yes, sir.
And now the next question is give reasons. We have done this question. Why do they take back basically hands in the backward direction? Because it
Yes.
increases the change in time of momentum. That's why the force basically is hurting less on the hands. A gun
Okay.
recoils. Definitely done this question in the class. These are the two
Yes.
questions we have discussed in the notes. We must be having those. Yes,
Yes.
Harshita? Yes, that's
Yes.
right. Define momentum. Easy peasy question. Momentum is basically the product of the mass and velocity of a body, and
Yes.
it basically gives the idea the quantity of motion in a body, which will have more momentum if a cricket ball and a tennis ball thrown at the same speed. Definitely a cricket ball, because cricket ball is made up of cork and leather. So leather is basically having more mass as compared to tennis ball. If you
Okay.
basically throw the same with the same speed, an object move through a distance, can it have zero displacement, Harshita? No. So basically, yes,
No.
yes, it can have zero
Yes, sir.
displacement.
It can have zero displacement.
Yes, yes. We have done this question in the class as well. You must be
Yes, sir.
remembering. I've given you such a homework question in the test as well.
Yes, sir.
Right. Next is a bus starting from rest with a uniform acceleration. Find the speed acquired and the distance traveled. Simple question of the equations of force. Okay.
Okay, sir.
If
This
so,
one
this
also.
speed acquired would be v equals to u plus 80. So 1.1 into 120, 12 meter per second. First would be 12 meter per second. Dist- Distance travel would be zero point 0.1 into 120 into 120, 60, 60, 70, 72 meter. First one would be, this would be 72 meter, right, Harshit?
Yes, sir.
Great. Derive an expression, Harshada. We have done this thing, Vishay, in the class. The
Yes, sir.
expression, right? You basically have to say that F is equals to G M mm by R square, and for weight of the body is mg. If you equate
Yes.
both the values, G would be equals to Gm by R square. The three-step calculations.
Okay, sir.
Explain why the value of G changes from poles to equators. I have told you the radius of the Earth is not constant. It's because Earth is not complete sphere. it is basically kind of elliptical. So on the equator, the radius is more. That's why the G value is less. On the poles, the value of R is less. That's why the G value is more. That's why the value of G changes from equators to poles. Clear, Harshita?
Okay, sir.
This is also in the notes you must be having. Have you noted down? Did you basically mention the same answer in the copy as well?
So I mentioned like this only, sir, like about the radius only,
Okay,
and
then it's
also
fine.
okay, sir.
Then it's fine. It's fine. Yeah, next is Hima is basically a high school student conducting an experiment in the physics lab. She sets the car in motion at regular interval. Chike. So you have to study this graph. Calculate the acceleration from A to B. 25 minus 0 divided by 3. 25 by 3 meter per second square. First answer. Calculate the retardation from B to C. Simple. 25 and this is 15. That would be minus 10 divided by 1. That would be minus 10 meter per second square, right?
Yes,
Attempt
sir.
either 1 or 2. Find the distance traveled by the body from A to D. Simple, using the triangle formula, right? But
Yes, sir.
if you push, say, yes, she can. So here the graph under this thing would be nothing but the area or the distance traveled, right? Hello,
Yes,
yes or no,
sir.
Harshita? So in that case,
Yes,
what you can do,
but
A,
I actually took part by part, like the triangle,
that
then
is
the
also possible. That is also possible. Both answer would be right. That is also possible.
yes,
Because
sir, because
ultimately,
like B and C, it is not like a straight line, so that's why I thought of taking like that
in this,
in.
see, let's see this thing. Half base into height is 6. Height is what? 25.
Okay,
Did you
sir.
get the 75-meter answer?
Mhm. Sir, it's actually been a long time. I kind of forgot some of the
Okay.
answers.
See, कोई बात नहीं. See, if you take part by
Okay,
part,
sir.
see. Half base into height, this is trapezium, this is half base into
Yes,
height. ठीक है?
yes, sir.
Let's do. Half base into height means 3 and 25. 25 divided by 75 divided 25 into 3 would be 75 divided by 2 plus trapezium. 15, 25 would be 40 and divided by into 1 divide
Mhm.
into 1. It would be 20 plus
Okay,
half
sir.
base into height, which is 4, 15 into 2. It would be 15, right? So 35 divided by 75, 37.5, 37, 35, 35, 70. The answer is right 3 and 25. ठीक है, divided by 2 plus a 25 and 15, 40. Height is 1 divided by 2, 20. ठीक है, 15 into 2 divided by 2, 15. Yes, the answer would be somewhat 37, 72, something like that as well. Okay. So,
Okay,
okay. So because if you take this thing,
yes.
the height is basically this and base is basically this. Yeah. So if you talk about
Okay,
the if a car moves in a circular path of radius 2r, what will be the distance covered after completing the 2 complete rounds? That would be 4 pi r after 2 rounds, and displacement would be 0 because it is coming at the same point. State Newton's law, derive the mathematical formula. We have done this thing.
yes.
Mass half kg is resting on a frictionless table. Calculate the acceleration. With no issues, acceleration is nothing but force upon mass, which is equals to 0.01 divided by 0.05. That would be equals to 1 divided by
Divided by
50.
5.
10,
50.
10, half 50. So it would be equals to 0.02 meter per second square. Okay. Next is when a piece of paper is under a pile of books, suddenly the pile books remain undisturbed. Why? The reason is basically the inertia. The inertia of the books remain as it is because you took it very fast. So that's why. Okay. Next
Okay,
is
sir.
on what factor does the inertia depend? Mass. Explain with the help of
Yes.
suitable example. Simply, if you basically sitting in a car we will go into forward directions, or any other example could be given. Deduced first law of motion from the second law of motion. It's nothing but
So I
basically
feel
the.
like they are told to give an example with inertia which is dependent on the mass. Right?
Could you please
Or
repeat?
just like they have told you in like on what factor does inertia of a body depend? Explain with the help of a suitable example. So we have to give an example regarding like we have to show that inertia depends on the mass.
Yes, basically it's up to you. Like there are multiple examples. You can also take the example. Suppose a truck and a car is there. You are trying to push a car. It can be easily be movable, but truck cannot be. So such kind of examples are basically, it's up to you. Like how do you basically use it, right?
Yes.
Just give me a second.
Hmm? Explain example.
Any other doubt, Harshita?
No, sir. That's all.
That's great.
So we're going to the new chapter, or are we
No, no,
revising?
no. We will be doing the revisions and numericals. Yeah, because we have
The
completed four.
gravitation is pending. Some of the topics.
Gravitation. Ha, some of the topics. Yeah, we'll do that. Yeah.
Okay, sir.
Just a second. I think we have done last. Yeah, we have done till mass and weight, right?
Yes, sir. We have to start from thrust and pressure.
So basically, the paper was very easy, and everything came out from the notes and the numericals we have discussed in the classes, right? So,
Yes.
so that's a very good thing, right? And hope like sometimes happen, like you might make silly mistakes as well, but don't worry. Okay. So how much like in physics in total, in basically the paper was of 80 marks, right?
Yes, sir.
So how much you're expecting out of 80, right? Any specific idea?
So I will get A1, sir. Actually,
A1, that means above 70.
that means like above 70.
Oh, okay. Okay, now let's discuss the thrust and pressure. What do you mean by thrust and what do you mean by pressure? So these two, the thrust is very similar to the force that we are going to discuss. Okay.
Okay, sir.
Okay, so the first of all, we are going to understand pressure, because after pressure you'll be able to understand the thrust properly, because thrust is a force which is perpendicular. So unless and until you
Okay.
don't understand what is pressure, so you okay, after that you will be able to understand the pressure, thrust. So the first thing that we have is you must be hearing about pressure, right? Put some pressure on it. If you are basically pulling something, pushing something, you are basically applying a force and you are pushing it. Because when you apply something, when you basically apply the force on something, so you're also applying the pressure on that thing, right? So basically,
Yes, sir.
the region on which you're applying the force, and basically that force upon area, that such thing, that quantity comes out to be nothing but pressure, right? So pressure is basically the force acting perpendicular to the unit area. Okay?
Okay, sir.
And is that clear?
Yes, sir.
Okay. So that's what the pressure is. So the formula, just give me a second. Let me just Yeah. So the formula for the pressure is basically force upon area, and this this force must be perpendicular to the area, right? If you're standing, if you're walking, everything you are doing, basically you are exerting some pressure on the earth. So that's why it basically a perpendicular force, Arshita, right?
Yes, sir.
Right. And the SI unit of pressure are to Newton per meter square and Pascal.
Okay, sir.
Chicken. And basically,
Yes.
so Harshita, the same force can produce different pressure because it depends that how much area you are basically taking to exert some force, right? It depends on the area. If the area is small, the pressure would be high, the pressure would be great, right? Massive. But if the area is small, the pressure would be sorry, not if the area is bigger, the pressure would be small, and if the area is small, the pressure would be bigger. Because suppose that, Harshida, when you basically trying to stick a nail into the you can say the wall, you are basically the point tip of the nail is very, very sharp. Why? Because when you basically struck that with the hammer, the pressure exerted on the nail would be very high. That's why it goes into the wall easily, right? But if the basically if you
Yes.
take a blunt nail, if you try to put it down into the wall, it won't go easily because the area is very big, right?
Okay, sir.
Okay, so please note it down, Harshita.
Yes, sir. Yes, sir, I've completed.
Just a second. Just give me a second, Harshita.
Okay, sir.
Yeah. So the next thing that we are going to discuss, as you can see, Harshita, the force, basically the pressure is directly proportional to the force, right? It means that if you apply more force, the pressure would be more. Yes or no, Harshita?
Yes, sir.
Okay. Next thing about the pressure is, as you can see, Shita, the pressure is inversely proportional to the area. That means if you have the smaller area, the fraction would become bigger, because if you have the smaller denominator, the fraction would be bigger now,
Yes, sir.
right? So in that case, the pressure would be more if you apply the same force on a smaller area, right? So that's why basically the pressure would be more on the smaller area, but on the same force, if the area is bigger, the pressure would be small. Okay?
Okay, sir.
So please note it
Yes,
down as well.
yes, sir, I've completed it.
Yes. Okay. So we are going. Okay. Next thing, as you can see here. So when a force on the larger area of an object, it produces small pressure. But if the same force you exert on the smaller area, it produces very high pressure. Okay. So Harshita, please try
Oh,
this question and let me know the pressure. What should be the pressure value?
So I for the unit of pressure, I can write both n by m square and also Pascal, right? Sir?
Yes, yes, it's up to you. Both are SI units.
Okay, sir. So is it 50 n by m square?
Yes, yes, yes. Please do this question. And here the force here you will be basically wondering that what will be the force. Please try and have a look at the question first, right? And calculate the force.
Okay, sir. Yes, sir, I've completed it.
Yeah, let me know the answer, Arshita.
So the pressure is 50 lakh Pascal.
50 lakh Pascal. Yes, that's right. It's
Okay.
500 into the power 6. Yeah, that's right. Please do this question.
So G, can I take it as 10 meter per second square?
Yeah, it's a yes, it's
So first I have to find like the total pressure of it.
well, first you have to find the देखो Here the value is given, you have to calculate the area first. And area will be
Yes, sir.
calculated in centimeter square, but you have to convert it into meter square because SI unit
Yes,
of area is meter square, right? Then you have
yes,
to
sir.
calculate the mass, which is 4, the weight, which is 4 into 10, 40 Newton. And then
Yes,
you
sir.
have to divide that with the area. Okay.
Okay, sir. So then what is this 50 centimeter into 25
50
centimeter?
centimeter into 25 is the basically the dimensions of the length and breadth, because the rectangular dimensions are length into breadth. Na? So area needs to be calculated in length into breadth. That's how.
Okay, sir. So I've completed it.
Okay, Ashita.
So
Great.
the
Please
first
let me
one it is 320 Pascal,
320 Pascal. Okay, let's calculate. Yes, that is correct. Second one.
1600 Pascal.
Oh, no, that's right. That's right. Now let's talk about the thrust. Okay, so this is all about such kind of questions would come into the exam, right? Based on your thrust and pressure. Okay.
Okay, sir.
Is that clear, Harshita?
Yes, sir.
Great. So the next would be, so just give me a second. Okay, so the next thing is basically thrust. So basically thrust is nothing but the force which is acting perpendicular to the surface. That force is called thrust, right? So whatever the force which is acting perpendicular to the surface, it is called as thrust. Okay. And thrust is the total force acting on the surface of a body. So whatever the surface is covered by that body, and if you're applying the perpendicular force, that would be called as thrust, right?
So can you give like an example?
Yeah. So suppose that a space shuttle is standing like this. So when the space shuttle is going upwards, it provides basically, it's the gases basically exert some pressure on it. So whatever that force exerted by gas on the ground is perpendicular. That's why the basically rocket goes directly into the sky. So that
Okay.
is called basically thrust. Okay, when you are standing,
Yes.
your legs basically exerts pressure on the basically your the surface perpendicularly. That is also called thrust.
Okay, sir.
Okay. And basically
Yes.
thrust formula, if you instead of force, if you write down thrust upon area, the pressure formula is also correct.
Okay, sir.
Yeah. Please have a note, please note this down.
Yes. Yes, sir. I finished it.
Wait. Yeah. And explain, okay, so there are some basically day-to-day life in which basically we observe the thrust, right, and pressure basically. So you must have seen that the school bag strip that we use basically to hang down on the shoulders are basically much wider, right? If suppose that you have a very small strap of the basically hanging part of the bag, it would hurt you basically, so that they will leave the scars. The area would become red on your shoulders if you have very small strap of the bag, right? Instead of that, very wide strap are made so that the pressure on your shoulders are not that much, and you are basically that it is very feasible to carry that basically the bag on your shoulders, right? So that's why
Okay.
the straps are made up of very wide area. You must have seen that it's wide area straps, right? And if you take
Yes.
that if the area of the straps are very small, and if you take that bag on your shoulders for a very long time, they would hurt you, right, Harshita?
Yes, sir.
Right? So and next thing is basically a sharp knife have a very thin edge, right? You must have seen that the knife that we use, we sharpen it. Why? Because when we sharp that knife, the area of that cutting region becomes very thin. That's why when you apply very small force, the area is very less. So that's why the pressure is much more as compared to a blunt knife. Because if you try to basically cut down the vegetables or anything without a unsharp knife, what would happen? It will not cut. But once you sharp it will cut very easily, just like a butter.
Okay, sir.
Next is the tip of the sewing needle is very sharp, very small. Why? Because it basically it will go into the fabric without tearing it. But if you take a swing needle, have a very large area, it would tear that. It will basically tear that cloth when you're trying to sew it. Okay.
Yes, sir.
Next is basically Harshita, when a man is walking, and then at that time only one foot is on the ground when you are walking. Obviously one foot is at the ground, one is basically a little bit above the ground when you are walking, right? So due to that, the force of your weight of man falls on a single area, that means single leg. That's why when you're standing on a single leg, you exert more pressure as compared to the double leg when you're standing on both feet, right, Harshita?
Yes, sir.
And tractors are made up of broad tires because Harshita, tractors have to go in the loose soil instead of going on the rock solid road. So that's why the tractor area, the area of the tractor tires are very, very broad, basically big, so that they do not apply much pressure on the soil and they can easily move into the soil. Right, Harshita?
Yes, sir.
Great. Sure. Please note it down and let me know once done. If not, if you do not complete it, we'll discuss in the next part. Don't, no, not an issue.
Okay, sir.